Well, good afternoon. Welcome to today's webinar entitled Storm Stress, Assessing Hurricane Vulnerability in Planted Longleaf Pines. I'm Karen Brown with the Longleaf Alliance, and we are very happy to have two great presenters on this topic. First, Seth Bigelow will take us through some of his recent work measuring damage to planted longleaf pine stands following Hurricane Michael, which struck North Florida and South Georgia in 2018. And following Dr. Bigelow's talk, Paul McDaniel will provide an overview of the resources available from the Georgia Forestry Commission to forest landowners who may have experienced loss or damage from natural disasters. Before we begin, I have just a couple of quick notes about the webinar format itself. We are actually in a Zoom meeting format, so I do ask that everyone keep their microphones turned off and their cameras turned off throughout the talk. We encourage you to add questions for either presenters in the chat box, and myself and my colleague Lisa Lord will monitor that and possibly respond to quick and easy things. We'll then have a chance to have the presenters field those questions at the end of their talk. Sorry about that. So without anything more there, I wanted to introduce Dr. Seth Bigelow. He's a forest ecologist and fire scientist. He investigates the ecology and management of southern pinelands using tools from the ecosystem, community, and physiological ecology. He's a research ecologist at Tall Timbers Research in Tallahassee, Florida. So Dr. Bigelow, if you are ready, I'll just have you take over the screen and begin from here.
Aaron, thank you so much for inviting me to present a webinar for the Longleaf Alliance. Can you hear me okay?
Yes, I can hear you great.
Okay, and it's wonderful to see all those names of people who have signed in, and I see there's some old friends I haven't seen in a while. So this is really exciting. And so when Hurricane Michael hit back in 2018, there was a lot of forest damage and a lot for forest scientists to study. And I and my partners here decided that given that landowners and land managers put so much effort into planting and tending longleaf pine stands, that we would focus on that and see if we could learn anything from the hurricane damage that would benefit those stakeholders. My partners in this study are Andy Whelan foremost, because he did many of the analyses I'm going to be showing you today, did many of the graphics, and he wrote a wonderful paper that I'll tell you a little bit about. Also of the Jones Center, Jeff Cannon and Stephen Brantley. And then at University of Alabama, Greg Starr and Christina Staudamer. In my title here, I say with, because I prepared this presentation myself, and any interpretations that are given here are my own. They're not the interpretations of my co-authors necessarily, or God forbid, of my employers or former employers. So it's reasonable to ask what the odds are of one's planted longleaf pine stand being hit by a hurricane. Well, fortunately, we have this wonderful paper by Jeff Cannon and Andy Whelan, among others, that came out recently that classifies the entire northern hemisphere into different hurricane zones, and they superimposed hurricane tracks and figured out which parts of the land had certain probabilities of having a hurricane go over them. And here, the orange area is the place that is most likely to have, or excuse me, most likely to have a longleaf pine growing on it. And Jeff and his co-authors calculated that that orange area has about a 1 in 8 chance of having a hurricane strength winds pass over it over a 30-year period. So substantial. Now, my goals for this talk are to show predictions of a tree damage formula that we made after in the wake of Hurricane Michael. It predicts damage based on stand structure and on wind speeds. I also want to show how this formula connects to a longleaf pine management tool, the density management diagram. And third, my motivation is to help motivate you landowners and managers to assess and be more knowledgeable about hurricane risks of your lands. Uh, Not being a true expert in this field, I did a literature review before I undertook this project, and I learned, not surprisingly, that higher winds mean more damage. Protection by other trees is helpful, kind of shelter. Trees raised at lower stocking levels, fewer trees per acre, are may have less damage because they become more wind firm. They have these responses called a thigmo response. So when wind pushes a tree, moves a tree back and forth, it begins to develop different cells, different xylem in its wood that are smaller cells that have more uh, smaller lumens and that are just stronger in the direction of sway. And higher taper, so diameter to height ratio, is also beneficial. And I'm using taper in a specific sense that wind scientists use of this diameter to height ratio, and not in the more general sense that foresters may use it. And so it's logical that taper would be beneficial because it's just like having a wider base for that, if you think of the tree as a triangle. And finally, recent thinning. So thinning within 5 years makes a tree more vulnerable because it hasn't yet undergone this kind of thigmo response that makes it more wind firm. I mentioned density management diagrams, and I want to introduce or refamiliarize those of you who may already know about them for management. And over here, I'm showing a density management diagram specifically for longleaf pine that was developed by Shaw and Long and published in 2007. And we have on the vertical axis, we have quadratic mean diameter of a stand. So that is the diameter at breast height of the tree that has the average volume in that stand. On the horizontal axis, we have trees per acre or density. And you'll see a number of solid black lines that are descending diagonally across this space that's defined by quadratic mean diameter and trees per acre. Each one of those lines represents a different stand density index, essentially an index of crowding. And to give you a sense of how this might work, I'm going to try the annotation here. Let's say we had a stand that had a density of 1,000 trees per acre. And the average, the quadratic mean diameter of that stand was a little bit over 2 inches. Now, let us say that this stand was tended very carefully over a number of years. And as the trees grew in size and got more crowded, uh, frequent thinnings were done so to reduce the density. And So you'd kind of move up along this line if that was your goal, until you might ultimately end up at a place, if you were a very skilled forester, where you had 100 trees per acre with a quadratic mean diameter of 10, uh, 10 inches. So all along that, you've just moved along the 100 stand density index line. So the relative crowding of all of those trees, even though they've grown bigger over time, because you've thinned them, the relative amount of crowding has remained the same. Now, and a stand density index of 100 that's thought to be about the level where trees start to compete with each other. Still a fairly open stand. This 100 trees per acre, 10 quadratic mean diameter stand would have a basal area of 50 square feet per acre. And so if we looked at 400, the outermost line here, that's the theoretical maximum amount of crowding you could get. That's trees packed in, cheek to jowl like sardines in a can. 250, this next line down from there, is when competition starts to get intense and you get self-thinning. I have to mention, very importantly, there are these dashed lines that go more or less horizontally across the diagram, and those indicate the height of the topmost trees. And uh, is my sound okay? I'm getting some sound coming in, but I'm leaving my door open because I'm boiling in here.
Seth, no, we're not picking up that background, but you're coming across just great.
Okay, great, thank you. So um, the the dashed lines indicate the average height of the tallest 40 trees per acre in the stands that were used to create this diagram. And sometimes it hangs up when I use the annotation, so I'm going to have to fiddle with it for a sec and try and get it to move. There we go. Okay. My annotations have remained. Well, we'll just leave them there. And so the density management diagram, it can be useful to, if you're trying to move your stand along keep it at a stand in density index. It's important to know how different kinds of thinnings will influence the stand density index. A low thin, in which you take out all the smaller trees, is going to lead to a higher the higher quadratic mean diameter. So that's going to move you kind of upward in the space of the diagram. A row thin, or a strict row thin, where you just take out an entire row and regardless of size of trees, in theory, that should have you moving just horizontally across the diagram as you reduce trees per acre, but the quadratic mean diameter should remain the same. And then finally, if you do a crown thin, where you take out some dominant and co-dominant trees, that should drop you down rapidly in quadratic mean diameter, and should drop you a little bit in trees per acre. So you can see how the effects of these different kinds of thinnings in this in the diagram space. And I have made it hang up again. Come on now. There we go. Hurricane Michael, of course, came through on October 10th, 7 years ago, roared into Mexico Beach And as you see down here in the diagram on the left, the red box shows the space that we worked in, and it was a Category 1 hurricane when it made landfall. Thanks to the programming abilities of Jeff Cannon, we were able to recover a map of the wind speeds and across the path of the hurricane and the directions. And so down here where the hurricane made landfall, as you see in the scale over here, we were in the neighborhood of 130 miles per hour, and a very wide hurricane. The path kind of of destruction got narrower as it went north, up into Georgia here, and then it kind of started to drop down to a Category 1 or less tropical storm force up there in Baker County. You see a lot of dots there that are represent stands at Ichauway, where planted longleaf pine stands, where we took measurements. And we took measurements across the entire gradient of wind speeds of the hurricane, so that we would be able to build this relationship between wind speed and damage. This is a picture of the stand where we saw the most damage at Chipola State Forest, down in the Panhandle, and 110-mile-an-hour winds and 95% damage. Really impressive to see the devastation. People in this picture here are Andy Whalen, very important. We also have Andrew Arco with his back to us, and Aubrey Plymel, and they did all the work, most of the field work, and so we're grateful to them. We used a mathematical model to kind of make sense of the wind and damage data. And essentially, we worked with this kind of model. You say, well, what kind of damage would we see if things worked like this? And then we compare the amount of predicted damage to the amount of damage we actually saw on the ground. And if it's not a very good match, then we go, okay, how about if we change the model a little bit and try it again? So we do that over and over and over till we get a model that can predict something that's a good representation of the kind of damage that we saw on the ground. And by damage, we're using the forester's definition of, was the tree converted to unacceptable growing stock? And our model was pretty simple in that it was a linear model, straight line. It just made straight line predictions, but it did have some interactions in it between different factors. And many of those interactions turned out to be statistically significant. So finding number one, greater damage at higher wind speeds, not surprising. I'll be showing a series of these graphs in which we have probability of damage on the vertical axis, and that's shown as a fraction. So 0.2 would mean a 20% probability of damage. And I usually split up, I have something like wind speed or density on the horizontal axis, here wind speed in miles per hour. And then I'll usually split up the model predictions into a couple of different factors. Here, mean stand height, 1340 or 66 feet. And when you see these kind of colored ribbons overlapping one another, that means that there really wasn't much difference among the factors here, the stand heights. And conversely, when they're separated, that means that they were statistically significant. Our second finding, lower damage probability at increased canopy cover. Andy Whalen did this sophisticated GIS analysis in which he took imagery from right over where we did our plots, and he measured out 300 yards and drew a circle around that. And then he converted the the photograph into an estimate of tree canopy cover, yes or no. Then he divided the circle up into pie wedges, and he asked whether the amount of cover in the pie wedge where the wind was coming from was related to the amount of damage that we saw. And sure enough, they were related pretty strongly. And as you may be able to see here from the graph on the right, um, on average, when we had about 50% forested cover in the direction the wind was coming from, then we had a little bit more than average of 20% probability of damage. And that dropped down to 10% when you got to 90% cover. Taper, as we suspected, is important and protective. Um, And on the left, I'm showing you an image of a tree with extreme taper, a bonsai, and that's got maybe a 2-inch diameter at ground level, and it's a foot high, so its taper would be 2 inches per feet. Here I have in the figure, I show taper on the horizontal axis and damage probability on the vertical axis, and in the taper in the middle of this picture is about 0.15 inches per foot. There's a big difference in damage probability for depending on the relative height of the trees. So the orangey stripe up high is a tree that's 1.5 times the average height of the stand. And so when a tree that's sticking out above the rest like that has a small taper, small base, it's spindly, gets knocked over readily. And if it's conversely, if it's shorter than the rest of the stand, it's in good shape. And it's not until you get to about 0.2 inches per feet that difference disappears and you really start to get some good resistance to wind damage. And as I mentioned in the previous graph, taller or smaller than average trees are protected. And so here on the graph, I'm showing the blue line is a tree of relative that's basically the average stand height. And the ones that are half average stand height, the gray lines at the bottom, they're just sitting right down there. And they are well protected. The tall ones are going to get damaged. And again, there's this density interaction here. So let me go to the next slide on that. So trees in dense stands are less likely to be damaged if all else is equal. So if you have two stands where the trees are same height, same taper, but in one stand the trees are dense, more dense than the other, the trees in the dense stand are going to be better protected, and which makes sense because the the wind is blocked better by that density. It doesn't seem to be very strongly related to the mean stand height, but definitely a factor. So to quickly recap what we saw, substantial risk to trees from a Category 1 hurricane, as we can all imagine. Trees that are more spatially extensive are better protected. High taper, about 0.2 inches per foot, is protective. Tallest trees are most vulnerable in a stand, and there's safety in numbers, and which is a little bit at odds with what I told you from my literature review about open grown trees. But I believe this safety in numbers we're able to make that assertion because we're able to separate out that taper effect from the density effect. And these findings are peer reviewed And you can find them in a paper by Andy Whalen in 2024, Damage Prediction for Planted Longleaf Pines in Extreme Winds in Forest Ecology and Management. This um, measurement, the stand density index measurement, is something that any landowner can do for their stand, and it's pretty. I think it's a useful thing to do, and I recommend it for anybody, if only to empower you and kind of engage you in understanding stand development. Tools are pretty simple. You just need the trusty diameter tape shown here on the side, paper and pencil, maybe a calculator. You measure the diameter of random sample of trees in a stand, which you can get just by going straight down a line, for example. You take the square root of the average of the square diameter to get the quadratic mean diameter. And then you also need the density of the stand to get the stand density index, which you can get if your trees haven't been thinned yet. You can get it just from the spacing of them. You measure the distance across the rows, measure the distance between trees in a row, you multiply those two together, divide it into number of square feet per acre. So for example, if you have 10-foot spacing between rows and you have 6 feet spacing within rows, that's 60 square feet per tree. Then you divide 60 into 66 times 660. I always like that way of remembering how many square feet there are in an acre, because 66 feet is a chain, and it actually comes out to 720 trees per acre in this example. So not long ago, I came up with this idea of, hey, couldn't we apply our damage prediction formula to the density management diagram? And the caveats that I have to give you right now is that it's not yet peer reviewed. It's not actually reviewed by anyone other than myself, may have some mistakes in it. I think it's essentially correct, however. It applies because I use the height of the top 40 trees in the stand to estimate the taper. It only applies to the top, to the tallest trees within the stand. And there's also a number of assumptions that I've made to show this probability. And they're essentially they're supported by the data set that we collected. Tallest trees, 25% taller than the mean stand height, 79% mean canopy cover, which is what we measured in our sample. And we can do this for any wind speed, but I just chose 74 miles per hour. Hurricane Category 1 hurricane wind speeds. And I had to make a relationship of DBH to quadratic mean diameter, which was based on, again, what we observed for the tallest trees in the sample that we made. And so here is my diagram. Again, it's modeled after the Shaw and Long 2007 density management diagram. We have the quadratic mean diameter on the vertical axis. We have trees per acre on the horizontal axis. I did not mention before that these are logarithmic, so the spaces between numbers get closer together along the axis as the numbers get larger. Then we have these stand density indices again. So, sorry. Stand density index of 100, the blue line, 250, 400. And then I hope you'll also be able to see that we have little blue dots. And each one of those dots represents one of the stands that we visited in its in the condition that we reconstructed it to be before the hurricane. And you you can see right off the bat, I think, that we didn't get any stands that were near the theoretical maximum of the 400 stand density index. Most of the stands were between SDI of 100 and 250. And maybe a quarter of a third of the stands were in this very open grown condition, that, which is below stand density index of 100. So the fourth element of this graph is this red contour map of damage probability for large trees in a stand at 74 miles per hour under varying combinations of trees per acre and quadratic mean diameter. And so putting this together was an eye opener for me, because just looking at the effects of the individual factors, as I showed you a few slides back, uh, I noticed that, I mean, I wasn't able to pick out the density effect wasn't super strong, but when I put it all together in this graph, the density effect is really strong. And even in a perfectly well-managed stand that you're keeping it open condition here, as the stand develops, you move up, let's say this blue line, you're still moving across these contour intervals, and the stand is still becoming more vulnerable to wind damage. And that you get the highest kind of like the contour lines basically are running north and south here. So if you were to do a thinning in one of these stands, and you wanted to avoid crossing too many of these dangerous contour lines, you could consider either doing a low thin, which would take you up and cross one or two of these dangerous contour lines, or you could do a crown thin, which would take you steeply down and also might cross one or two of these contour lines. However, a row thin just takes you across, you may go across an extra contour line. So, so with a great deal of caution, I am suggesting that maybe varying different kinds of thins might have less of an effect on the increase in hurricane damage vulnerability. So again, recommendations made with a bit of trepidation and caution. First, thin when stands approach SDI 250. Now, an SDI 250 stand is not a stand where you're going to have great wiregrass growing. You're not going to get Bachman sparrows down in there. You're going to sacrifice some habitat values in those dense stands. However, based on our data, it occurs to me that, it appears to me that there may be, if you want to really optimize your hurricane resistance of your stands, you may need to sacrifice some habitat values. Again, a recommendation made with caution and caveats and all that. I do think it's clear that multiple small thinnings are better than a few large ones. And I think it's always good to experiment around with different thinning types. And again, it does seem to me that erring on the side of higher density during the first decades of stand development is likely to be most protective for hurricane risk. Want to close with a quote that's always stuck with me from Norman Maclean's Young Men and Fire, in which he says, they were still so young that they hadn't learned to count the odds and to sense they might owe the universe a tragedy. Now, for the Longleaf landowners and managers in this crowd here, I sincerely hope that you don't owe the universe a minor tragedy with hurricane damage in your stands. But I hope that we've given you some of the tools to help you count the odds. And here's Hurricane Aaron track as of yesterday on the left. Want to again thank our field workers, thank our funder, NSF, and sincere thanks for the wonderful institutional support from Tall Timbers and the Jones Center at Ichauway.
Thanks so much for that, Seth. Definitely a lot to kind of chew on and ponder, and a lot of really great science presented. We haven't fielded any questions in the chat yet, but I'm sure folks will plug those in as they think of them. Um, yeah, and really interesting to end on some of those practical recommendations for making different stands a little bit more wind safe. Um, we'll often, with a lot of the management that we'll talk to landowners about, particularly making big changes, sometimes we'll recommend, hey, doing some of these practices on some of your acres, not all. It sounds like there could be sort of some at-home experimentation and going on in some of those stands too, to try to apply some of those recommendations. Of course, you kind of mentioned the age and the density at which that would be appropriate. So I guess that's its own limiting factor.
Yeah, that's a wonderful idea. The precautionary principle is always an important one to remember. So rather than going whole hog, trying something out on a limited number of acres is a great way to go.
Well, yeah, if those in the audience have any questions, feel free to pop those in the chat, and we'll have another chance to look at those at the end of the hour. So Seth, if you can stop sharing. Next, we have Paul McDaniel from Georgia Forestry Commission. Paul is the Forest Health Coordinator for the commission. He's also served as a management forester and water quality specialist. And he is here to present on some of those resources pre and post storm. So yeah, Paul, looks like you're ready. Go ahead and take control of the screen.
All right, thank you, Karen. Yeah, I'm going to talk a little bit about some of the stuff that you can do both pre and post storm that can kind of help you prepare for some of these events that I have. I've been through two hurricanes, both Hurricane Michael and the most recent Hurricane Helene, so have a little tidbits on what we can kind of share on how to prepare for some of those storms. All right, so just going to go over quickly what I'm going to cover. We're going to talk about first preparing before the storm. What are some of the things that you should be doing right now to make sure that you're ready for when and if a storm is going to come? Just like we talked about earlier, the probability of you having a storm is there, so you should be preparing for it. Like any management plan, you should be preparing for it. Also, we're going to talk about how to assess the damage. We can talk some of the ways that we do it and some of the good and the bad of it, but some of the things that you can use to help evaluate how bad your damage is once you've been hit. Also, what resources are there post storm, what kind of help you can expect to have. This is going to vary from state to state, but we can go into what kind of help and resources or cost share programs might be available. And then some of the lessons we've learned over the years, with especially with the past two storms we've had, and then some resources that I recommend you bookmarking in your browsers and checking out to make sure you have those resources when needed. The first thing is pre-storm. This is always a recommendation for anybody who has forest land is to find a forester or a resource professional to help you manage that property. Whether it's, I know a lot of people may enjoy doing a lot of the stuff themselves, but it's always good to have a resource professional that you can bounce ideas off of. And just make sure you're not crazy when you're thinking about something that you want to do. I've met with landowners many times over the years, and they have some great ideas, but sometimes there's some biology and some other stuff that may limit that idea from coming into practice. And we can kind of your forester can kind of help set those expectations on what to expect. There's many different resources. You can always hire a consultant. Someone who's works in the private industry can help you sell your timber, help you plant your trees. They're always a great resource to have. But if you don't have the money to pay for a consultant to help you out, you can always contact the local county forester through your state agency, whether it's GFC or Alabama or South Carolina or Florida. Any of those have county foresters that can serve in limited capacities, but they're usually a good free resource to make sure you have a connection with. Most states will allow you to call them out and look at your property, give them a once over, and then they can give you some basic advice. And then at least once that storm hits, you're going to have a forester who's familiar with your property and can kind of give you a lot better advice with a quick turnaround than somebody who's never been to your property. You know, if the first time you call a forester is after you've been hit by storm damage, you're already going to be at the back of the line. While if that forester's already been on your property, they may not be able to get out there that day or that week right after a storm, but they can be familiar with what you have and can kind of lead you in the right direction. So that's what I talk about with building a relationship. You having that relationship with a natural resource consultant forester can pay real dividends once the storm hits. The other thing is have a management plan. A lot of people like to do it themselves, but have something written down on paper what your management plan is, you know, for at least 10 years. If you're confident enough to know what you're doing, I mean, by all means, you write your own management plan, but I would have a resource professional such as a forester write it for you, just to kind of give you that long-term perspective, so you know what your plans are, what your objectives are, what your goals are going forward, what inventory you do have, what age classes, when stuff was planted. Having all that is essential to help you move forward once you do get hit by a storm. You know, knowing the past can help push forward to where you want to go in the future. And also having a current stand inventory. This doesn't necessarily have to be a full cruise of the property. Sometimes just having a management plan can supplement for this, you know, where a lot of the management plans will at least have the age, you know, rough DBH of that stand when the management plan was written, some tree heights. So then that way, if a storm does hit, you have some documentation to show what that stand was at a certain point in time. That, you know, if you do have to claim some casualty loss or anything like that, you have something to go off of. But having a good stand-in inventory will help you even more to kind of know what you really have on the ground. So post storm, you know, once the storm hits, you know, obviously the biggest thing is to be safe, protect your family and your home. That should be step number one. Don't worry about the trees. They're going to be what's done has been done. Nothing that you're going to do is going to be able to prevent anything else from happening. So the first thing is be safe. But then the other thing I want to caution you is that it's going to look bad. Here's a picture. This is from Hurricane Michael. And you'll look at that stand, and you know, when just after a storm hits, you're gonna go, man, this is really bad. This stand has been heavily hit. I've lost everything. But when you start looking at it more critically, you're gonna see, well, actually, well, looks about maybe only this one spot got hit, and you know, that's about a half acre. And then when you really look at it, you might go, well, actually, it's only about maybe 40% of the stand that's a total loss. And so the more you look at it, the more critical you are, the better you are going to make, you know, your management decisions going forwards. You know, so you're going to have to temper your expectations. It's going to be bad, but just be ready to kind of look at it objectively. The first thing you want to work on is access. You know, obviously and the reason I say this, you want to be able to have a good look at what you have on the ground. So just from this photo, we can tell a little bit about what's going on in the forest, but not everything. You know, there might be some other pockets that are more heavily damaged. So first I'd focus on getting access to the property where you can get in and look and see what you have. And then work on clearing any roads or fire breaks. You know, that's step one. You know, some people immediately want to go into salvaging their timber, and in some cases that's the best thing to do. But you need to know what you have. And even something you might want to do to get a good perspective is throw a drone up. We did a lot of drone flying, especially after Helene. We were able to go and fly some drones over some properties and kind of get a better more 10,000 foot level picture of the stand to kind of see what the actual damage was across the stand. And that's something that I can get in there within a few days after post storm, probably a few weeks to be able to evaluate what you have on the ground. And again, make sure you um, assess the stand objectively. Use a forester. That's going to be where having that relationship beforehand, having a previous forester you've been using, they know what your objectives are. You may be wanting to manage for wildlife. You may be managing this stand for timber. They're going to help you really key in on what management you should do going forward, and they're also going to give you access to markets. If you don't have any previous relationships with a logger or a forester, the chances of you getting storm salvage post storm is pretty low. Just to kind of give you some numbers perspective, during Hurricane Michael, of all the damaged trees, only about 19% of the damaged trees were actually able to be salvaged. Because once those trees break, you only have so long before they start drying up, and then they can't be used at the mill. Whether that's pulp or plywood or saw timber. So there's a time limit, a ticking time bomb going to get this salvaged. And if you don't have any previous relationships built, the chances of you getting your timber cut is, I would say, almost next to nothing. Because they're going to be so busy working with the people they have relationships with, who are going to keep working with them going into the future. Um, they're going to be the ones that are going to get served first. And then also you may want to afterwards do a cruise, and this will come into being important because if you want to start claiming casualty loss and stuff like that and timber loss, you're going to need to have a good cruise to be able to justify those numbers. And then there's certain techniques that foresters can do where they can do stump cruises, and what they can do is they can measure the stumps of the trees that were left, and then measure some what we call witness trees. Some of the trees that are left and the remaining, and we can use that to kind of use some regression models and be able to kind of grow back to timber what it was, and get a stand density based on what's been taken down and what was lost. So again, having a forester is a huge asset, after the storm. So let's talk about damage assessment categories. When we do our damage assessments on a state level, these are the three categories we look at. We have light damage, moderate, and then catastrophic severe. It used to be four. We used to have catastrophic and then severe were two separate categories, but we found the difference between what management options on a catastrophic stand and a severe stand is basically the same. So usually that's going to be clear cutting. It's so great. Greater than 50% of the stand is damaged, heavily damaged. That's usually a clear cut and replant. So again, this is going to vary across your property. If you have hundreds of acres, you may have some areas that's light damage, some that are moderate, and then some that are these catastrophic severe. So you need to evaluate on a case by case basis. So something that we call light damage is if there's less than 10% of the stand is damaged. This is usually going to be just broken branches, some minor stem damage. You may have some trees leaning. Over here, we talked about density earlier. This is a heavily dense young stand here in the bottom right. They're leaning against each other. So there's not a lot of damage. There's some leaning trees, but you'll notice most of the trees are leaning less than 45 degrees. There's a lot of studies that show that once you get past a 45-degree lean, the chances of that tree sitting back up straight are pretty low. And that comes into account too when you have ice storms. How much lean. I've actually seen some. I will say we had some ice storms on some longleaf that I helped a guy manage, and some of them were laying on the ground after the ice storm. And I came back about 2-3 weeks later, and they were standing straight back up. So there is some stuff where some of these trees will start to stand back up over time, especially on the younger stands. They tend to stand up and be a little bit more malleable for some of these storm damages. So then we get into moderate damage. That's going to be 10 to 50% of the stand is damaged. With mostly broken stems and tops. Again, this is less than half the stand with this. Your trees bent more than 45 degrees. Trees uprooted. And this is where your management plan is really going to come into effect. If you know what you're managing for, this is really going to help make decisions on how to manage that stand going forward. Because when you get to these moderate 10 to 50%, you know, you're going to have to make a lot of hard decisions on where you want to go forward. When you get to catastrophic, severe, 50 to 100%, it's an easy decision to do a clear cut, replant. That's probably going to be your best decision. But these more moderate stands, um, it may come back. You may do a thinning in a couple of years. You may come back and you may just leave it as it is. If it's only 20% of the stand, it might just be worth it to wait till your next thinning to do some harvesting. And I'll show you a slide later why that's important too. Because the good thing when you have these moderate damaged stands, a lot of them, the roots, you may have some leaning trees like this one over here might be leaning, but the roots are still attached. So that means that tree can still grow and still have moisture, and it's still going to be marketable going down the road once when the markets recover. Um, so let's talk about help post storm. I know I'm kind of running close on time. I want to leave room for questions, but the big thing post storm, call your forester. You want to have some healthy salvage. He's going to be your queue in to get that stuff. He can help you with your documentation for casualty loss for timber tax. And there's a lot of stuff that goes in that. We'll talk about a little bit about that later. Some resources on taxes. The biggest thing post storm is also contacting your local forestry agency. They're going to know what cost share programs are coming down. Just some examples, some cost share programs to expect, especially some of the bigger storms. One's the biggest one is called EFRP, or the Emergency Forestry Restoration Program. This is funded through federal dollars, the federal program through the Farm Service Agency or FSA. And it usually covers stuff like debris cleanup, site prep, tree planting, and this is a 75% cost share. So you still have to spend money in order to get money back to get reimbursed. But some of the practices and how this changes from every year. So this one you need to really call and talk to your state people before you start doing work with EFRP. And you need to get signed up too. Something people don't think about EFRP, until you sign up for the program, all the stuff you've done beforehand usually doesn't count towards the cost share. It's everything after you signed up for it. So just keep that in mind. But still, sometimes they go back and will allow you to document stuff right after the storm, but you never know. Then you might see some state funded cost share programs come through. I know in Georgia with Helene, we were able to get some state funds to come down to do some fire break maintenance and clearing and road clearing, and also some debris cleanup as well. Since EFRP has a limit of, I want to say it's either 300,000 or $500,000 that you can get from EFRP. So a lot of people had a lot more damage than that. So the state stepped up in Georgia to fund some additional debris cleanup. So a lot of people are doing both programs in order to help with debris cleanup. Then also with there's will be sometimes block grants that come in. This is usually from the federal level, and this will help offset some of the costs of timber loss. That's where having a cruise ahead of time or an idea of what your volumes were at a certain point in time, so you can grow back that stand using some cruising methods, and you can estimate your loss. And then, like I said, that's for the timber value. So that's different from a casualty loss. It's a little bit different. Talk to your accountant about that one. And then the other thing is timber casualty loss. This one can only be as much as the basis you have in your timber. If you don't know what your basis is, call your accountant. They're going to be your link to really help with that. And this is where, a lot of people won't have a lot of basis in their property to be able to claim on a tax casualty loss. So this is where a lot of those block grants come in to kind of cover that gap of what you may not have in your basis. Some lessons learned, real quick, just it's going to take a while to get what you need, to be patient with people. Just be patient. Other things is some forest health things to be thinking about is after storms, we see a lot of Ips beetles outbreak on a lot of forest stands post storm. We're starting to see that with Helene. We saw it with Michael. The biggest thing is avoid damaging any trees that are already stressed. They may not look stressed, but they've gone through a heavy wind stress, even though some of the smaller stands. So try to avoid damaging any of your residual trees during cleanup. Monitor for any invasives. A lot of new equipment is going to be coming in and out of your properties. to help with cleanup. Make sure to monitor that invasives don't move in on some of those equipment. They may not be washed or clean, moving from site to site. One of the biggest ones is cone grass. And so if you find any cone grass, make sure to report it and get it treated. But you're really likely to see a lot of invasive take off post these large storm events. Also watch out for your fraudsters. That's where having a good forester involved is going to really help you make sure you get good contractors to come out and do work on your properties. The other thing is the warning that timber prices are going to be bad. This is timber prices post Hurricane Michael. You'll see there's a big dip. That's when everyone was trying to salvage their timber, but you'll see the prices come back up eventually. So if you can ride it out and you don't have to salvage right then, try to wait out trying to salvage your timber. We've told a lot of people that with Hurricane Helene. We made some of those decisions on some of our state lands that were just moderately damaged. The trees were still in the ground, had root connections, they were alive. So we're waiting out until some of the markets come back and sell some of that timber when the timber prices are a little bit better. So try to wait out the slump if possible. Here's some quick resources to consider. For taxes, there's a whole website called timbertax.org. On our public website, we have a whole section on natural disaster recovery. Feel free there's a lot of good resources there on what to do. Some publications I may point you to is there's one by Dr. Dickens with UGA about assessing storm damage in forest stands. And it really breaks down how to assess the storm damage. And we have a publication about IPS beetles and storm damage, stuff to look out for post storms with IPS beetle damage. And then some stuff about selling storm damaged timber. This is a good one. You're going to have losses. Here's some recommendations on how to sell that timber. And then, I talked about leaning and uprooting trees. There's a good publication about the response and recovery after major storm events for leaning and uprooted trees. That's also hosted on bugwood.org or Bugwood Cloud. That's a UGA site. And like I said, I've given Karen a copy of the presentation, so she should be able to share you these resources and all these links. And with that, does anybody have any questions?
Well, if anyone does, definitely reach out to Paul if anything comes up, and he can either help you out with that or put you in touch with the right person, depending on your question. Thanks, Paul. That was really informative. I definitely took away a couple of new things from your talk. And yeah, I will definitely make this talk available and those links especially. Some of those sound really useful. Just wanted to jump back into the chat box. It looks like a few questions for Seth, but it looks like for the most part, Seth, you've addressed all of those and we can all see those. So that made some good use of time. Is there anything else that came up that you wanted to add for the good of the group as we head into closing?
Just wanted to thank everybody for attending and really appreciate it.
Yeah, of course, of course. Well, since we're coming up on the hour, I just wanted to thank both of you, Seth and Paul, for sharing your work and taking the time to share that with the landowners on the call and partners. I'd also like to thank Wade Research Foundation for sponsoring this webinar, and thank you to all of you for joining today. This session has been recorded and it'll be available on the Longleaf Alliance's YouTube page. We have a webinar playlist where you can find other topics. So that's where this one will be housed. And feel free to watch it and share it. Share it to these YouTube, Tall Timbers. That's what it's here for. So yeah, thank you again, everyone, and we hope to see you soon. Take care.